Welcome back. In today's lesson, we're going to be finishing up our discussion on the shapes classes, and we're going to be talking about the polygon and polyline classes. Now, the polygon class defines a polygon that connects a sequence of points. These points have to be following the rules of a polygon. Therefore, they all have to be they have to have convex angles, and they all have to connect, so there can be no point that's completely open. A polyline, on the other hand, is identical to the polygon, except it's not automatically closed. So it means that you could have a hexagon almost with 5 points, where one of the edges is infinitely long. Therefore, this is the difference between a polygon and a polyline, is that if you need to have something that is closed, use a polygon, and if you need to use something that isn't closed, use a polyline. Now, since you're probably going to encounter more polygons than you will polylines, today we're going to be implementing the polygon class. Although everything we talk about works perfectly well with the polyline class, all the methods, all the data fields, the only difference is you wouldn't have as many points. Now, you have a variety of constructors here. You have the noArg constructor, and then you have the polygon constructor with the specified points. This is a variable arguments list, so it can be 1 point long or it can be 100 points long. It's completely up to you. However, if it's a polygon, remember, it has to close in on itself. The Java virtual machine will automatically link these points together. All you have to do is appropriately enter them, and it'll link them in the order you entered them. In addition, we have the getPoints method. This getPoints method returns a double values of the x and y coordinates of the points as an observable list. This allows us to therefore, once we get this list, we can modify it and add to it, allowing us to better use that list and add points to it that we want to later on. Now, today we're going to be implementing this with a practical demonstration of a polygon. We're going to be drawing a hexagon. So, we're going to import the polygon class. We're not going to be using the polyline class in this case, however, as I mentioned, the only difference would be you would have 1 fewer points. So, we're going to import the JavaFX.scene.shape.polygon. And with that, we've now imported all the appropriate classes. Now, all we have to do is create a new pane. Once again, we're only going to use a basic pane here, since we don't need to have any specific situations. All we need is the pane to display our hexagon. So we're going to say the pane, and this is going to be pane 6, is equal to a new pane, no arguments, and then we can create our new polygon object. This is one of the few cases where you might actually use the noArg constructor on a shape, because with a polygon, you might not know how many points you have. So you would create a noArg constructor, and then you would add as many things as you could to the list with using the observable list method that we have, the getPoints method. So we're going to create that new polygon. We're going to call it polygon, and it's going to be equal to a new polygon. And as I mentioned, for the reasons I mentioned, we're not going to have any arguments on this because we don't know our points yet. So we're going to say we also immediately are going to add this to the pane. And this might look a little bit counterintuitive, since you might be saying, well, in every other situation, whenever we wanted to add something to the, whenever we wanted to add a shape to the pane, we always did that at the end. Now we're not going to do this time. We can actually add it right now and just keep on modifying the polygon because of that getPoints method. Using the getPoints method, we can then get the list, and then we can just keep on adding to the array list, or to the observable list, as though we hadn't added it to the pane, and it'll automatically update the polygon that's already sitting in the pane. So we're going to say pane6.getChildren.add, and then we're going to add polygon. And now we don't have to do that at the end of our program. After that, though, we can set the fill color and the stroke color for our polygon. The fill color is going to be white, and the stroke color is going to be black. It's a fairly standard polygon. You can actually change the color to whatever you want. In our case, we want it to be fairly boring. So we're going to say polygon.setFill, and then we give our color, which in this case, as I mentioned, is going to be white. After that, we can set the stroke color, and so we're going to say polygon.setStroke, and then we provide the color .black. Now you could use the setStyle method and use your JavaFX CSS, however, we're only adding 2 things here, there's no real need. After this, though, we come into the real point of why we're allowed to add it immediately to the pane and the power of that getPoints method. What we're going to do here is we're going to create a new observable list. This observable list will be storing double values. And remember, this is in contrast to the other types of shapes we've talked about, where everything was always a double property. This is not a double property. It cannot be innately bound to the xy coordinates, that is. So we're going to say list is our reference variable is equal to the polygon dot get points. So what we're doing here is we're harvesting basically the list from the polygon get points, and we're just assigning it to the list that we've created called list. Now this is important because it means that later on we can just keep on adding to the list as though it was the polygon list, and it would work perfectly well. In addition, because this is an observable list, we have to make sure we import the collections class. You have a choice here. You can either import it later on, or you can give the exact address, but we're just going to import it here. That's why I didn't do it at the beginning. It's not necessary. After this, though, we can now get started on designing our hexagon. Now we have an option here. The way to create a good hexagon is to give a specific height and width, and then from there we can start working with that height and width to create the appropriate hexagon. So that's what we're going to do. We're going to create a final double width and height, both of which will be equal to 200. This is because we want a square window at the end of this. So we're going to say the final double width is equal to 200. Then using our combined notation, we're going to say height, since this is of the same data type, is equal to 200 as well. Then we're going to say that we want the center x and center y to be equal to the width and height divided by 2. This will appropriately give us the right locations for our height and width of the, or I'm sorry, for the points of our, or the starting points of our rectangle, of our hexagon, those being the center points we want to work with. Now it's important to note, in case you're not aware of this, a good way to figure out the points on a hexagon is to imagine that you had a radius. That radius would be equal to the distance from the center to a point. Then you could calculate 60 degrees worth of rotation, or you could calculate 1/6 of the area. The way to do that would be to say 2 pi divided by 6. This will give you the xy points that you can manipulate, and therefore you can figure out the center xy and then the xy. Using the cosine method, we can then figure out the points of an appropriate hexagon. This is going to be a regular hexagon, by the way. And using the cosine method, we can figure out the appropriate points for our hexagon. Then we can add that to the list, and then we'll have these 6 points for our hexagon with an appropriate center. But first, we have to create that center x and y. That's going to be equal to the width and height divided by 2, since it needs to be smack dab in the center of the window. So we're going to say the double center x is equal to width divided by 2, and center y is equal to height divided by 2. Fairly standard here. And then after that, we can create that radius. Now the way to create a radius for this situation would be to say you want to get the width and height, you want to find the minimum of them. In this case, it's not too relevant. However, we're going to define it as though the width and height were different. So you would get the minimum of the width or height, then you would multiply it by 0.4 to get your appropriate radius. So we're going to implement that. We say double radius is equal to math.min, which is our way of getting the minimum of two numbers, of the width and the height. And as I mentioned, in this case it's not too relevant, but in case you did have a different height and width, this becomes very important. And then we multiply this by 0.4, or divide it by 2.5. After this, we can now start to add each of these points to the polygon list. Now the way to do this, as I mentioned, is we're going to use the cosine method. We're going to say 2 times I multiplied by math.pi divided by 6. This is the way to get every single appropriate point. Then we multiply this entire thing by the radius and add the center x to this to get the first point. Then we would add the to get the x coordinate. Then to get the y coordinate, we do the exact same thing except we subtract the center y instead of adding. So since we're going to do this 6 times and for 6 different points, it makes sense to have a for loop. So we're going to say for integer I is equal to 0, I should be less than 6, and then we want I to be post incremented. Inside the loop we're going to say list.add center x plus radius, and remember this will allow us to get the x coordinate of our point. And as a quick side note, the get points list takes the points in sequential order. So if you were looking down that array list and you set, or looking down the observable list, the first point would correspond to your first point's x coordinate. The second value would correspond to the first point's y coordinate. So that's why we can add them this way instead of having to add them simultaneously, which would be very, very clunky. So we're going to say plus the radius, then multiplied by math.cosine. And remember, this is where the real heart of getting the point comes into it. 2 multiplied by I multiplied by math.pi, and I mentioned this at the beginning, divided by 6. Then, to get the y coordinate, we're going to do something very, very similar. We change the center x to center y, and then we subtract the radius instead of adding it. So, hopefully you found this useful, but after this, we still have to create our scene. Except the advantage is, since we have a specified width and height, we don't have to create those with the scene. We have those variables, so we can pass the pane and we can pass the width and height, all of which are going to be variables. So we're going to say scene, and we'll call this scene 6 is equal to a new scene with the appropriate pane, and in this case pane 6, comma width, which is what we created up here, which is the width of the window we want, and height, which is the height of the window we want. Then we can create our new stage. We're going to say stage 6 is equal to a new stage, no arguments on that. And then we can set the title. We'll say stage 6 dot set title, and then we give our title, which in this case is going to be show polygon. And then we can now set the scene by saying stage 6 dot set scene, and then we provide our appropriate scene, which in this case is going to be scene 6. And then finally we can show this out to the user by saying stage 6 dot show, and now this will be printed out to the user on the appropriate window. And one correction before we run this program: this should actually be sine, because of the way that the because of the way that a radius and circle work. This has to be the sine, otherwise you wouldn't get valid points as they would be overlapping. So sorry about that. But now if we run our program, you can see we're going to see our polygon, and now you can see it. We have our 6 points appropriately constructed, and especially because we corrected that error. You see our 6 points, and then you see that it's all connected, which means that it's an appropriate polygon. If you wanted to run this program as a polyline, all you'd actually have to do is convert this 6 to a 5, so it would cut down 1 iteration, and therefore would have 1 empty edge, and therefore you'd also have to change all of your polygons to polylines, because otherwise you'd run into errors. So hopefully you found this lesson useful. To summarize, what we've talked about in the past few lessons about shapes is that every single shape is built on usually a pane, and they have very common methods, such as the set stroke, such as the set fill method, all of which apply. In addition, some things that you might not conventionally think of as shapes still are considered to be shapes. In today's lesson, though, we talked about the polygon and polyline, and we implemented it by creating a polygon to show. Hopefully you found this lesson useful, and hopefully you're able to apply all that we've talked about shapes in your own programming.